So in this presentation, I'll be talking about what exactly a data center is, including some of its components and uses. And then I'll be discussing its professional implications for myself, particularly in the field for software as a service. And then obviously I'll show my sources at the very end. So to get started with data centers, when we're talking about a data center, we're talking about a central location that does a number of things. One, it houses critical IT infrastructure like servers, but this also includes fiber optic cable, routers, cooling systems, right? A lot of infrastructure that businesses or institutions maybe used to keep on premises that now they can outsource to a data center. All of that infrastructure then also helps provide reliable processing and dissemination of data. So this is where we get the cloud. And so if you've used Apple's iCloud or Google Drive or even a little more sophisticated systems, data centers are crucial pieces in providing that processing power. And then finally, data centers are, because of their central nature, security is of the utmost importance. And so a lot of that security is done through redundancies in personnel, both in terms of operators and actual security personnel, equipment, and environmental controls like HVAC or fire controls. The physical locations and designs can vary, so very small data centers might not actually be called data centers. They might be something like a server closet or a server room that maybe a school or a business has on their own premise. But the bigger data centers are usually nondescript warehouses from the outsides. They share the same basic components, but maybe look a little bit flashier depending on which company owns them. And then you also get kind of unusual features, maybe like Microsoft's underwater container server farms that they're experimenting with in Scotland right now. So the biggest names in the industry for data centers are Amazon Web Services, Google, and Microsoft. But of course, there's hundreds, if not thousands, of other providers of data centers around the world as well. So in this diagram, we see kind of the typical layout for a data center. So beginning in the center there, you can see the server racks, or sometimes called the server farm, where you have hundreds or even thousands of computers working as servers. And because you have so many of them there running almost nonstop all the time, they also generate a lot of heat. And so some of the other features we get here are aisles where the hot air all blows towards a central location that then can be vented to the outside, and then often a raised floor where cool air is pumped in from below to help cool down those machines. You also have uninterrupted power systems. So the bigger data centers are connected to public utilities, but they also might have their own power stations. Many of them have battery backups and then also generators in case of power failure so that the servers themselves never go down. And then as you move towards the outside of the building, you start to get into the personnel offices. So this can be anything from the engineers to the facilities people to the receptionists, even though these places don't usually have visitors, all the way outside to guards that maybe work the gates or patrol the premises. So I mentioned redundancies earlier, and those redundancies are what really create reliability for these data centers. And so you have redundancies in security. And so if people watch the Google Cloud Services video that was included with the project, you kind of got a sense of those redundancies where many of these data centers are surrounded by fences. You have to show ID to get on premises, and most people aren't going to have adequate ID to do that. You're going to have actual security guards manning the gates and patrolling the grounds, as I said earlier. There's going to be cameras that overlap so that you can't really escape being on footage. And then you get some of the high-tech James Bond type security features, things like retina scanners and fingerprint scanners or biometrics. And then you also get security for the data itself in the form of firewalls and encryption that maybe add an extra layer there. You have redundancies in power, like I already mentioned. So they may be connected to the utility grid, the public utility grid, but then those battery backups and generators are also going to be there that can switch on almost instantly so that there's no interruption in service. And then you have redundancies in data. And so, of course, all these servers are hosting data, right? They're serving as storage and then the processing power when people want to access that data. But if something were to happen to the physical servers themselves, that data can be migrated to other servers, either on premise or even a different location somewhere else in the world, so that users never actually notice any sort of interruption to their information. So now I'm going to talk a little bit about why these data servers kind of matter in my work. So I work for a software company, and one of the kind of collections of services we provide are known as a service, or AAS. And so there's a couple different versions of this. You have infrastructure as a service, or IaaS, and data centers are a perfect example of that. The infrastructure is the actual hardware, and sometimes including the people who maintain that hardware, what maybe traditionally was an IT department for a business. But that can now be outsourced into a separate location at which different businesses all pay that same data center or that same service, a subscription, to access that equipment. You have platform as a service, or PaaS. PaaS includes that infrastructure, but then also grants users the ability to develop their own applications using a platform. And so you may have heard of some versions of this, things like Salesforce or Microsoft Azure, or even Google's App Engine would all be examples of a PaaS. And then the most common and kind of most comprehensive version of this as a service business model is software as a service, or SaaS. So this includes things we all use, like Netflix and Microsoft Office 365, or cloud services like Dropbox or Google Drive. But then there's also kind of industry specific ones. So my particular company, for instance, we service the hospitality industry. We provide software that does pricing analytics for hotels and casinos and resorts and things like that. And so we rely on infrastructure as a service ourselves, but we also provide platforms and softwares to our users that they can access from anywhere without having to develop or host it themselves. And so here in this graph, you can see kind of a nice overlap of the three as a service models. So infrastructure as a service includes those service and storage, the networking, firewalls, and security, and then the actual physical location itself. Platform as a service will include that, but will also add on operating systems and development tools or databases. And then finally, software as a service will include all of the before mentioned, and then also include those hosted applications or apps, right? So my particular company, these data centers actually come into play quite a bit. So we utilize SAS, as in the SAS Institute over in Cary, North Carolina. We use their data centers as well as Amazon Web Services. SAS also relies quite a bit on the Microsoft Azure platform. And so one of the things that I encounter quite a bit at work is we will have, brief periods of downtime, or we'll be working on a project and we'll get an alert that data is being migrated from one server to another. And that is happening completely offsite, completely out of our hands, but just kind of an ongoing maintenance issue. So within the company, we are a global company. We're headquarters in Minneapolis, but we have people here in North Carolina. We have people in the UK and Europe, in India and China and Japan. And so all of us work at the same time with the same applications, with the same data in real time. And so that is an example of utilizing the cloud, right? And the cloud relies on those data centers to provide that reliability and instantaneous access to information. And then externally, our software as a service model means that when we have users subscribing to our service, they are accessing their data as well as our platform instantaneously from wherever they need it. And this includes, global hotel chains like Hilton, and it includes little boutique bed and breakfasts that maybe have, one or two locations on Martha's Vineyard or something like that. And so this also shows kind of the power of a data center is that it can service anyone. That scale of information and scale of processing power is really crucial to a lot of businesses today. And then I'll flash my sources up here very quickly. Um, I will point to a couple that SAS, which is my company's parent company, actually hosts a blog called the Data Roundtable, in which they talk about data management and big data and what does the cloud mean for the tech industry or the analytics industry quite a bit. And so it was actually useful to see those kind of internal company sources relevant to this project as well.